All right, as the Word document says, we're going to start trying to learn how to graph in Python. We're going to use matplotlib and pyplot. Won't that be exciting? Notice it says matplotlib.pyplot as PLT. We've been importing these, and we're going to import math even though we won't use it quite yet. We will use that in our second. I just have a tendency to include it. Pandas will get used later. All right, now to actually do our graphing, we want to have fig equals plt.figure. This is so that what we generate is a figure that we can do something with, and you'll see that in a moment. We're going to use a plot style using Seaborn White Grid, and that's simply to give us a grid in the background, and it makes looking at the graph a little bit easier. At least I think it does. And then AX equals PLT axes. This puts axes on the graph, and it puts some data into the axes for you automatically. And we have some verbiage on that we'll skip for the moment. I'll have this Word doc on Canvas for you. I'm going to use something called a linspace. Notice that it doesn't have the E. The number of times I've typed the E and had it yell at me, I'd think I'd know by now. And it's just for generating linearly spaced vectors, i.e. we're going to get effectively a list, but it is really a vector, but no big deal. And we're going to use x is equal to numpy np dot linspace 0, 10, 1000. So what this is going to do is generate 1,000 points equally spaced from 0 to 10. And what I'm going to ask you to do as part of your homework assignment is to vary this number and see what happens as you change the value of 1,000, making it smaller. Making it larger won't do much. Making it smaller will. All right, and then we're going to say that that's x. We printed out what type it is just so that we could see, and it tells us that it is, I think I've got this, yes. It says class equals numpy nd array. All right. An array is basically like a list, but it has some restrictions, and we're not going to worry too much about that at the moment. And when we printed it out, we got how long the list was. And I then threw the rest of it away. All right. So let's look at the code and see if we can figure out what's going on. So I'm going to graph y equals mx plus b, get a hopefully linear plot, and that should be a plus, not an equals. There we go, y equals mx plus b. I'm going to choose that the slope is going to be 3 and the intercept is going to be 5. I'm now going to have my y values be a list, and I'm going to say for n, every number in x, which was my array, I'm going to say that the y value is equal to m times the x value plus b, and then I'm going to append it into my y data list, and then I print out the length, and then I plot x versus y. Well, that was not exciting enough, so giving myself a little more space. So I said y2 is going to be another array, or another list, excuse me. y2 is a list, and again, for each of the numbers in x, then y value 2 will equal n squared. So I'm going to effectively be graphing y versus x squared. And then y2 dot append that value and plot those two. So I should end up with two graphs, or two lines, excuse me, on the same graph. And there we go. So the blue line, being a straight line, is going to be my y equals mx plus b. Notice that this is, if you look down in here as I'm running over the graph, you'll notice that that point is approximately 35 and 10. Well, we went from 0 to 10, and 3 times 10 is 30, plus 5 is 35, so that's pretty good. And then this is y equals x squared. So at 10, we're up to 100. Ooh, 99.82, that's pretty good. Having a lot to do with how, where did I actually put the mouse. So the point of all this is I can have multiple graphs or multiple lines plotted on the same graph for comparison. And you can see that our linear and our curve cross at some point, which we could calculate where they cross, but then after that the exponential goes up much more quickly. All right, so to recap, we imported NumPy PyPlot as PLT, and we're going to use math later. We put some things in, a figure to get that figure of the graph. We chose the style so that we had the grid in the background, and we plotted the axes, which got the numbers on the axes. And I defined what x was going to be, and it would be a evenly spaced set of points, 1,000 of them, between 0 and 10. And then I said that the slope of my line will be 10, the intercept will be 5, and I've now got a list for all the y values. And I have an equation that puts the values in for y, and then I plot x versus y. I then said, well, one line is not enough, so I said, let's do a square. And so I now have my data for a square, and I plotted that out. And as we saw, I got everything I was supposed to. Notice this says figure 1, so this is the fig that we were referring to before. Okay, in the next installment of this exciting adventure, we will actually do projectile motion.